Okay, so now that we have our point and our slope, then we can finish this because we set our tangent. We're going to use what we learned from Calc 1, which is take your slope at your point, plug into point slope form. So we have, in order to finish this, we'll have y minus y1, which our y value is 3, slope at negative 2, and then times x minus our x value, which was negative 2. So it's minus a negative, so that's going to change to a plus. So we get negative 2x minus 4, and then add 3 to both sides. And we get y equals negative 2x minus 1. And that is our tangent line to the parametric curve, defined as this at the value t equals 3. The second part of this question wanted us to find the second derivative at this point. Okay, so continuing on with this question, we are supposed to find the second derivative. So to do that, I've written down some generic steps for you here. The first step is we want to find the first derivative of y with respect to x. So to do that, we need to find our dy dt over dx dt. We already had a lot of that done up here. I just didn't do it generically because what I did up here was I went ahead and plugged in 3. So now we need to keep this generic. So I need to take my dy dt value and put it over my dx dt. So I have started that process down here. Of course, there's going to be a lot of algebra involved. So my first derivative of y is going to be equal to, I need to simplify this. I think the first thing I would do is go ahead and cancel out the 2's. And then we have a positive over a negative, so I know it's going to be negative. And then we've got 3. And then this square root, because you would multiply both top and bottom by square root of t plus 1 to get rid of it. That square root's going to come up to the top. So we'll have negative 3 times square root of t plus 1 over the square root of 3t. And I think I would leave that there. There's some minor simplifying that we could do with these 3's here, but I don't think I'm going to worry about that right now. Okay, so the second step is, once you find that, we want to find the derivative of y with respect to t. So I need to find the derivative of y prime with respect to t. I misspoke a little bit. So that means I need to take what I just did, and I need to take the derivative of that with respect to t. So my second step is to find the derivative with respect to t of what I just found. So I'm going to call that negative 3 over square root of 3. I'm just going to put the constants out in front. And then I've got square root of t plus 1 over square root of t. So now I need to make a decision on how do I want to do this, because there are several different things you could do. I'm going to go ahead and simplify these. For one, we could go ahead and just leave this the way that it is and take the derivative using quotient rule. We could put them both underneath the square root, which would allow us to think of this as square root of 1 plus t to the negative 1. And then we don't have to mess around with quotient rule. So it's really up to you, algebraically speaking, how you want to leave it before you start taking the derivative of it.